In the very beginning of algebra history, algebra did not look like how we think of algebra today, with arithmetical operations, variables, functions, and polynomials. Mathematics was done all rhetorically, so it only consisted of words. And a lot of algebraic identities that we know today have geometric interpretations. Diophantus was the first to introduce the idea of using letters to represent an unknown variable and subtraction. And due to him, the stage of notation moved on from rhetorical algebra to syncopated algebra. However, because technology advancement was lacking, the symbols were not used consistently nor widely. Diophantus also introduced an important concept of algebra, which is generalizing, in his unique pattern of presenting his problems. This was very different from other Greek mathematicians of his time who only gave a solution for a specific case. Al-Khwarizmi is known as the father of algebra, who introduced algebra, which means to restore, and this became the root word for algebra. Although he comes after Diophantus, his works was done all rhetorically. His text is a standard text of the Islamic mathematical world, with a hybrid system of Indian decimal numbers, accepting 0 as a number, and Mesopotamia's fraction base of 60. He starts off with introducing equations that are linear or quadratic and are composed of units, roots, and squares. He is influenced by Euclid as Al-Khwarizmi's geometric justification to finding a solution for his equations are similar to those in Euclid's Elements. It was during the Renaissance period when notation started to develop and spread quickly at a low cost due to the invention of the printing press. However, the process was still a little rough because so many mathematicians from different time periods and places used symbols differently. Therefore, although the idea of using symbols spread much more in the time during Diophantus, they looked very different until Thomas Harriot. As you can see in the table, what was written as 4x squared plus 3x equals 10 all look very different until the last three mathematicians, which we can kind of guess what they are because they look similar. Yet, during this period of notation development is a big influential factor to the last stage in notation, the symbolic algebra. 18th century is when algebra begins to look much more like what we think of today, and the modern stage of symbolic algebra. The diversion of algebra from geometry occurs most during this period. As symbols are used more universally, algebra begins to form its own identity. There were three important mathematicians who started to shape algebra of its own in the beginning. In this video, I will focus on one, Newton. In his text, Arithmetica Universalis, Newton started at an elementary level but developed a comprehensive course with many interesting details on the solution of algebraic equations. He focused on the basics of solving equations and showing how to translate problems into algebra, including materials from geometry. Many of Newton's word problems from the book is very similar to those in algebra texts today. Here I have an example of a geometric problem but in systems of equations. It's question 3 from chapter 19. And the problem asks to find the hypotenuse of a right triangle given the parameter a and the area of b squared. Just with the given question, we can set up three equations. If we have L and K as the base of the triangle and H as the hypotenuse, first we have A plus K plus H is A. And second, we have L times K equals to B squared, because L, the area of a triangle, is B squared, and with the base times each other and half of that. And the third equation that we can get is the Pythagorean theorem, which is L squared plus K squared equals the hypotenuse squared. So we have three equations with three unknowns, which means that we can find h. So we first can set the equation L squared plus K squared, and then we substitute in equations to have a minus h squared minus 2 and 2b squared. So we organize the equation to have h squared equals ah negative minus 2ah plus h squared minus 4b squared. So we solve for h, and then we get a squared minus 4b squared divided by 2a.